Hello everyone, welcome back. In this video, I will demonstrate the Honda RA621H project, a web application that analyzes the Formula One engine assembly process using Kahn algorithms and the critical path method are running in the browser using Python via Pyodide. Okay, this is our project repository, and this is the application running via GitHub page.
Okay, the first step is set the things of the CFG or directly Acyclic Graph of all components and the dependencies on the left side. Okay, next in the right side, you can see this is a graph visualization. It's not regression. A Honda RA621H component. The arrow indicates a dependency relationship. A component of the end of an arrow can be assembled after the preceding component has been completed. We can do zoom in and zoom out. To explore the graph, the yellow color or the red color nodes represent a component that belongs to the critical path. See in this. Yeah, this is a critical path.
So, the second tab displays statistics calculated using Python pandas library. And remember, everything runs directly in the browser, not on a server. Here, you can see the distribution of components by subsystem, like ICE, turbocharger, MGH, MGT, energy source, and others. The I subsystem has the largest total duration because it represents the core of the engine. As you can see in this ICE. Next, I will discuss about the CPM. This chart shows the distribution of the float values. The leftmost column representing the range from 0 to 50 hours contains the most critical components. The further to the right, the more scheduling flexibility this component has. And this is the complete list of the components on the critical path. 11 components that cannot be deleted without affecting the overall project schedules. On the left side, there is a list of all components arranged in the topological order. The results of Kahn algorithm. Here, we can see the ES, LS, and total float for the component. When I click on the component, a detail panel appears. We can view its earliest start and earliest finish, latest start, latest finish, total float, material, weight, and dependencies. To close the panel, simply press ESC or click everywhere or set it.
Next, in the tab 3. Tab 3 will show you guys a visualization of step-by-step Kahn algorithm. Here we see the initial increase degree grid of all components. The number in each box is the number of prerequisites that must be completed before that component can be built. Okay, we will try, so I click play. Notice component C001 and so on, all those with an increased degree of pseudocode directly to weight 1. It can be worked on in parallel. If the process is in progress, completed boxes are green, like this, and new boxes are waiting for their turn, like this. Okay, once wave 1 is complete, the increased degree of the next component is decreases. Those with 0 go to wave 2 and so on. We can also jump directly to the next step using the next button, like this, and return to the previous step using the break button, like this, and a leave arrow button that skips all steps into finish, like this, and leave arrow button that skips all steps and return to the beginning, like this. On the right is a pseudocode that explains which steps are being executed in here. This helps us understand the algorithm visually. And that concludes step 3, so that the component demonstration of the Honda RA621H project. This project implements the Kahn algorithm for topological sorting, CPM for critical path analysis, pandas for statistics, and Pyodide for running Python in browser, all in one web application that anyone can access without any installation. Thank you and see you later, friends. Bye!